Hi guys, welcome to Module 48. So we're talking about pollution control measures. Let's look at our learning objectives. So after reading this module, you should be able to explain strategies and techniques for controlling sulfur dioxide, nitrogen oxides, and particulate matter, and describe innovative pollution control measures. So pollution is, we're still continuing with this idea of air pollution. So when we talk about how to eliminate air pollution, there's a couple things we have to look at. First, it's eliminating or avoiding using the things that are causing the emissions in the first place. So avoiding burning things like fossil fuels like oil and coal. If you can't avoid it, then try to use a cleaner version of that fuel, right? So you can actually lower the sulfur content of coals and oils by refining them further. Now, normally when you do that, it's going to cost a little bit more money because it's going to take more time, it's going to take more energy. So if you can't use a cleaner fuel, then maybe you should increase the efficiency and conservation, meaning you should just use less of that fuel, right? So if you can use less fuel, then you're going to produce less air pollution. And if you really can't do any of those things, then your last measure should be to control the pollutants after you're combusting them. And that's really what this lesson is going to focus on today. If we can't use cleaner fuels and we're still going to use fossil fuels like oil and coal and combust them, then we need to find a way to prevent those emissions from getting into our atmosphere, or at least decrease the amount of emissions that are getting into our atmosphere. And then these down here, fluidized bed combustion, wet scrubbers, baghouse filters, and electrostatic precipitators are a couple of the ones that we're going to be talking about today. So with those, what types of pollutants are we trying to control? The biggest ones are sulfur and nitrogen oxide emissions. We've talked about those quite a bit already. Those are the ones that are contributing to photochemical smog, to acid deposition, things like that. Particulate matter or particulates, and smog. So I mentioned these before. So fluidized bed combustion is generally used in the removal of sulfur. Catalytic converters are what are used for the reduction of nitrogen oxides. Baghouse filters are used to limit the amount of particulate matter. So are electrostatic precipitators. And then scrubbers are generally used for both particulate matter and sulfur dioxide. So we'll go through each of these individually and look at what each method or how each method works and sort of the reality of implementing those. Okay, so fluidized bed combustion. So this is really going to control your sulfur dioxide emissions, and predominantly from burning things like coal. This is, in terms of the reality of implementing this, almost all coal burning power plants make use of this fluidized bed combustion. In fact, when we looked at that mega sized coal burning power plant in England, it was called Dragnex or something like that. I don't know if you guys remember. It was a really dramatic video. They actually made use of this. They were making sheetrock or gypsum-based sheetrock out of their facility as well, and this was the method they were using to do that. So what they do is they take that granulated coal and they're going to burn it near something called calcium carbonate. Now, you've probably heard of calcium carbonate before. It's what makes up rocks and shells. A lot of aquatic organisms that have rocks or shells surrounding them have calcium carbonate in them. So it's naturally abundant. So they burn this coal near the calcium carbonate, and that calcium carbonate then heats up and absorbs the sulfur dioxide that's being released as a result of burning that coal, burning that fossil fuel, and then that reaction creates something called calcium sulfate. And calcium sulfate is one of the primary products used in making things like gypsum-based sheetrock. And sheetrock is this stuff. It's the kind of stuff you build houses out of. So if you were to peel away the layers in your wall, you would eventually get to something like this in your house. So by building this, we're allowing for this sulfur dioxide to be used for something useful instead of escaping into the atmosphere. So that's fluidized bed combustion. Next is temperature and oxygen control, and this one's really going to be looking at nitrogen emissions. So we know that about 78% of our Earth's atmosphere is nitrogen gas, which means any type of combustion reaction that we're going to be doing on this planet is going to react with the oxygen in our air and result in nitrogen oxides. And we know NOxes, or nitrogen oxides, are a predominant greenhouse gas. The hotter that we burn, or the hotter that these combustion reactions take place in, and the amount of oxygen, the more oxygen that's present, allow for more nitrogen to be released into the atmosphere. So if we can decrease the temperatures and decrease the oxygen supply, that will decrease the amount of nitrogen that's actually escaping into the atmosphere. The only downside to this is that we know that incomplete combustion reactions are reactions that take place with little to no oxygen or not enough oxygen, lead to different types of problems. They lead to things like carbon monoxide, which is toxic to humans, and could also lead to increased particulate matter. So those are things like incomplete combustion of things like biomass, right? So we could end up with more problems than we had before. Okay, catalytic converters. So catalytic converters are used mostly to eliminate the nitrogen oxide emissions that are coming from your vehicle, and carbon monoxide emissions, actually. So this is part of your exhaust system, although it's usually closest to your engine, or it's close to the motor of your car. And the whole idea behind it is it uses these sort of semi-precious metals, things like platinum and palladium, to basically filter out the emissions that are going to be coming from the combustion off of your engine. And the idea behind this is as these gases pass through this catalytic converter, this what they call a honeycomb shape, as they pass through here, it's actually going to decrease what the actual emissions are. So you're eliminating a lot of your carbon monoxide or your hydrocarbons, or in this case, your nitrogen oxides. And you'll end up with something more like just CO2 and water as your emissions. So catalytic converters are in every single car. This is actually one of the things they're testing for if you have an older car and you have to go get it smogged. I think your car has to be at least 8 years old to start having to get smogged. So if you have a newer car, you've probably never had to do this. But when you go get your car smogged, it's testing for the amount of emissions that are coming out of your car. And in the state of California, our emission standards are incredibly high. So you can't have too many emissions. And if you do, if your car is reading that it has too many emissions, then your car will not pass smog. You won't be able to register your car, and you won't legally be able to drive it. That's one of the measures that all states, and California is especially tough to pass, take in order to decrease the emissions that are being put in the air as a result of all the cars on the road. And because California has so many drivers, our emission standards are much higher. So a lot of the time when your car doesn't pass smog, it's because your catalytic converter isn't operating properly. So they would call, a lot of people in the car world would call this a CAT. So if your CAT isn't operating properly, they would have you replace the CAT. Now, because these are made of semi-precious metals like platinum and palladium, they're actually really expensive to replace, and some cars have multiple CATs in them. So this is like something you don't want to go bad on your car. Now, it won't harm your car will still be able to drive properly, but you won't pass smog and you won't be able to legally drive it. So this is sort of a bummer when this goes wrong. It's actually something that's commonly stolen off cars. When people who are looking to like recycle materials, they'll oftentimes steal catalytic converters off cars because they're easy to get to, and they sell for a lot of money. Now, this is also another reason why we no longer have lead in gasoline. Remember, we talked about the amount of lead emissions that are in the atmosphere, and it was the amount of lead that was sitting in our atmosphere was toxic to humans, and they started removing lead from gasoline, and it decreased dramatically. So one reason they took lead out of gasoline was to help with our atmospheric conditions, but the second reason was that the lead was actually negatively reacting with the platinum and the palladium that these semi-precious metals are made up of in these catalytic converters, and it was basically causing them to function poorly. So that was kind of another reason why lead had to be taken out of gasoline. So it kind of worked out well in two ways. Okay, so now we're going to look at controlling particulate matter. So this is our most common means of pollution control. Usually when we're talking about this, we're talking about just those little tiny particles that come as a result of combustion reactions. But in some of these, and I'll point them out to you, they can also remove sulfur dioxide from the air. So let's look at some of these. So the first one is gravitational settling. This is really easy. It's containing your combustion reaction and allowing gravity to make those particles settle to the bottom of a cylinder or a container in some way. Mix them in with some sort of liquid so they can no longer become airborne, and then dispose of that liquid concoction that's been made. That's gravitational settling. It's very simple. It's very straightforward. Baghouse filters. This is sort of like if you have a vacuum cleaner that has vacuum bags that need to be replaced. It's a fabric-based filter that basically gases can freely pass through, air can freely pass through, but the particulate matters can't pass through the can't pass through the small pores of these filters, and so it traps them, and then these filters can be disposed of. You've probably seen fabric filters before. In fact, actually, as we are all wearing these face masks for this coronavirus outbreak, that's kind of working in a similar way. And then electrostatic precipitators make use of high voltage electricity. So it basically charges these dust particles, and it allows them, once they become electrically charged, to be attached to something that has an opposite charge, like a metal plate or something like that, charged metal plate, and they attach to each other. And then once everything has attached to the plate, they can turn the charges off, collect the dust, and dispose of it properly. And we'll talk more about how that's disposed of properly once we talk about solid waste disposable or municipal solid waste. We just haven't quite gotten to that yet, but we will, because a lot of times some of the particulate matter can be heavy metals, things like that have to be disposed of in a very specific way. So how we dispose of specific solid waste depends on what it is. And then this last one is scrubbers. Scrubbers are the most common one, and these will actually additionally remove some sulfur from the air as well. But essentially what's happening, I'm actually going to move to this next slide to explain, is these happen like on top of smokestacks, essentially. So say you're at a coal burning power plant. You would have a scrubber sitting on top of your smokestack, and basically all the air, all of the exhaust that's coming off of your smokestack is first going to go through this chamber, and this chamber has all of these misters, or these little shower heads essentially, and the water is going to force all of that particulate matter to clump together and sink to the bottom of this chamber. So instead of it becoming airborne in here, it gets wet and heavy and falls to the bottom. So making use of gravity here, they drain this out, they put it in this sludge removal system, so you get this very thick sort of solution. They remove all the water from it, they dry it out, they dehydrate it, and then that sludge goes to a municipal solid waste facility or a landfill type thing where it's disposed of properly. And then the nice thing here is they actually reuse the water, so it just keeps going. But this is incredibly efficient. Like I said, it also gets rid of some of the sulfur dioxide emissions as well. And then whatever is emitted, although it's not perfect, is much cleaner than when it initially came out of your smokestack. Okay, so what are ways that we can reduce the amount of smog in the air? So we can reduce our VOC emissions. Remember, VOCs are volatile organic compounds, and they're the things that have a really fragrant smell to them. So things like gasoline, dry cleaning detergents, certain chemicals used at nail salons. There are natural ones, ferns or pine trees that have really fragrant smells, right? When we're talking about reducing our emissions of VOCs, though, we're talking about anthropogenic emissions of VOCs, so things like gasoline. And you can do this by trying to reduce the amount of gasoline you spill out of your gas tank when you're filling up your car, right? Things like that, or not using as many dry cleaning services. So with less VOCs means there's going to be less compounds that are going to be interacting with those nitrogen oxides, which means there's going to be a less production of ozone or breaking down of ozone, which means we're going to end up with less photochemical smog. And then we should also look at reducing our nitrogen oxide emissions. So most nitrogen oxide emissions come from the combustion reactions of any kind, not just fossil fuels. So limiting our combustion reactions, and more specifically limiting our combustion reactions, including fossil fuels. So how can we sort of on a smaller scale, maybe a city scale or a county scale, implement innovative pollution control measures? So what can we do? like I kind of mentioned on the previous slide, reduce gasoline spilled at the pump, restrict evaporation of those dry cleaning fluids, reduce your use of lighter fluid. Lighter fluid is something you would maybe spray on your fire if you wanted to get it going higher. That's a VOC. It's very fragrant, very pungent. Reduce your use of wood-burning stoves and fireplaces. Those are burning things like charcoal or wood, and we know that those are biomasses, and those biomasses have a really high amount of particulate matter in them, and carbon monoxide is a potential release in those as well. So reducing your use of those will reduce those emissions. And then, of course, limiting your use of automobiles. So some places are reducing it to only being able to use your car every other day instead of every day, and staying off the road when heavy commute times are happening. So there's less vehicles on the road, right? Okay, and the last thing is this an amendment to the Clean Air Act, which we've been talking about, and this has to do with reducing our sulfur emissions. So similar to having a sort of carbon, what would you call it? Having a limit to the amount of carbon you can emit. There's also limits to the amount of sulfur you can burn. So basically you get an allowance every year. People that are creating combustion reactions and burning sulfur can release a very specific amount of sulfur. Specifically, each company can release about 1 ton of sulfur dioxide per year. And if that company were to release more than 1 ton of sulfur dioxide per year, they would then have to pay for it. However, if a company is going to go over their allowance, and they know they're going to go over their allowance, they can purchase more allowances, but they're very, very costly. The reason we're trying to decrease our sulfur emissions is because this is one of the main causes of acid deposition, right? So we want to decrease the amount of sulfur that's present. If there are no more sulfur allowances left, so if a company's not willing to sell their sulfur allowances to you and you go over, then you just suffer the cost of what it is to go over. Okay, that was the end, so let's do some quick practice questions. So which method is used to reduce nitrogen oxide emissions? And in this case, the answer is A, the installation of catalytic converters. Which is not used to prevent the emissions of particulate matter? The answer here is D, catalytic converters. And then which pollution control method was proposed by an amendment to the Clean Air Act? In this case, it's a market for sulfur emissions, so the buying and selling of sulfur allowances. And if carbon monoxide emissions decrease from 145 million tons annually to 80 million tons annually, by what percentage have emissions been reduced? And the answer here is B. And to do this math, you would do 145 minus 80. That number divided by 145 times 100 gives you 45%. Okay? All right, guys, let me know if you have any questions, and I'd be happy to help. Have a great day.